Our picture of the universe. Stephen William Hawking, a British theoretical physicist, was the Lucasian Professor of Mathematics at the University of Cambridge and a Fellow of Gonville and College, Cambridge. He is known for his contribution to the fields of cosmology and quantum gravity, especially in the context of black hole, and his popular works in which he discusses his own theories and cosmology in general. These include the runaway popular science bestseller A Brief History of Time, which stayed on the British Sunday Times bestseller first for a record-breaking 237 weeks. Our picture of universes, taken from his A Brief History of Time. World belief. A quite long time ago, we believed that the world is really a flat plate supported on the back of a giant tortoise, standing on the infinite tower of tortoises. Most people would find this picture of universe is ridiculous. Thirst for knowledge. Aristotle and his philosophy. Around 340 BC, the Greek philosopher Aristotle, in his book On Heavens, was able to put forward two good arguments for believing that the earth was a round sphere rather than a flat plate. First, he realized that the earth coming between the sun and the moon, which caused eclipse of moon. The earth's shadow on the moon was round, which would be true if the earth was spherical. Second, the Greeks knew from their travel that the North Star appeared lower in the sky when viewed from the south. It appears to be directly above an observer at the North Pole. Aristotle thought that the earth was stationary and the sun, moon, planets, and the stars moved in circular orbits around the earth. A change in Aristotle's theory. A simple model was proposed in 1514 by a Polish priest Nicolaus Copernicus. His idea was that the sun was stationary at the center and the earth and the planets moved in circular orbits around the sun. The German Johannes Kepler and the Italian Galileo Galilei supported the Copernican theory. Johannes Kepler had modified Copernicus' theory, suggesting the planets moved in ellipses, not in circles. Galileo Galilei's views. In 1609, he started observing the night sky with a telescope which had just been invented. When he looked at the Jupiter, Galileo found that several small satellites or moons that orbited around it. Sir Isaac Newton's theory. In 1687, Sir Isaac Newton published his Philosophy Naturalis Principia Mathematica, in which he not only put forward a theory of how bodies move in the space and time, but also developed the complicated mathematics needed to analyze those movements. In addition, Newton postulated a law of universal gravitation, according to which each body in the universe was attracted toward every other body by a force which was stronger, the more massive the bodies and the closer they were each other. It was this same force that caused objects to fall to the ground. Newton went to show that, according to this law, gravity causes the moon to move in an elliptical orbit around the earth and causes the earth and planets to follow elliptical paths around the sun. Theories evolved in the 20th century. When most people believed in an essentially static and unchanging universe, the question of whether or not it had a beginning was really one of the metaphysics or theology. Everyone thought that the universe had existed forever. Edwin Hubble's observation. In 1929, Edwin Hubble made a landmark observation that wherever you look, distant galaxies are moving away from us. In other words, the universe is expanding. Hubble's observation suggested that there was a time called the Big Bang. He believed that time had a beginning when there was a Big Bang. One can imagine that God created the universe at literally any time in the past. God created the universe at the instant of Big Bang. A good theory. The author Stephen Hawking believes that a good theory is one which satisfies two requirements. First, it must accurately describe a large class of observation on the basis of a model that contains only a few arbitrary elements. Second is it must make definite predictions about the results of future observations. For instance, Aristotle's theory did not make any definite predictions. On the other hand, Newton's theory of gravity was based on an even simple model in which bodies attracted each other with a force. As a philosopher of science, Karl Popper has emphasized a good theory is characterized by the fact that it makes a number of predictions that could be disproved or falsified by observation. The theories will survive each time some new predictions are made. Einstein's general theory of relativity predicted a slightly different motion from Newton's theory of gravity. Goal of science. The eventual goal of science is to provide a single theory that describes the whole universe. Scientists try to separate the problem into two parts. First, there are laws that tell us how the universe changes with time. Secondly, there is the question of the initial state of the universe. Many people believe that God, being omnipotent, could have created the universe and created the laws for the universe. It is very difficult to devise a theory to describe the universe in one go. We try to split up the problems into bits and try to explain them, but it may be that this approach is completely wrong. It may be impossible to find a solution by investigating parts of the problem in isolation. Conclusion. Today scientists describe the universe in terms of the basic partial theories, the general theory of relativity and quantum mechanics, the great intellectual achievement of the first half of this century. The general theory of relativity describes the force of gravity and the large-scale structure of the universe. Example, nuclear energy. Quantum mechanics deals with phenomena on extremely small scales, microelectronics, revolution, and nanotechnology. Unfortunately, however, these two theories are known to be inconsistent with each other. They both cannot be correct. Today we are searching for a theory which will incorporate both the above theories. Hence, scientists are trying to put forward a unified theory which will describe everything in the universe. For the search for ultimate theory of the universe seems difficult to justify on practical grounds. It may not aid the survival of our species. It may not even affect our lifestyles. But ever since the dawn of civilization, people have not been content to see events as unconnected and inexplicable. Today we still yearn to know why we are here and where we came from. Our desire for knowledge makes us explore the universe, and we would like to know a complete description of the universe we live in.